Hi guys, it's Nakoda from ATP All Things Physio and welcome back to our channel. So in this video we'll be going through moments and torque. So what is it? There are two definitions I'd like to go through for this topic. The first one being moments is the turning effect produced by a force acting at a perpendicular distance on an object. The second definition is more in-depth, being the product of a force by the perpendicular distance from the line of action of the force to the pivot. Now this definition is very important because when we go into actually calculating perpendicular distances and stuff like that, for these calculations we would be looking at the line of action of the force. Now from these two definitions we can get the formula. So a moment, or M, is calculated by multiplying the force F by the distance D, right? Distance being perpendicular distance, right? So the unit for moment would be Newton meters. Newtons from force and meters from distance. Now realize distance is in meters and it is always in meters, not kilometers, not centimeters, meters, right? So from this, let's go to an example. So on this side we have a seesaw, right? Now let's add a force, since we're dealing with force and distances. So this force is acting downwards. Now we can see that from the line of action of the force. Now which definition we saw that in? We just see that over here, right? So the force is acting downwards, and to find the moment we need to find the perpendicular distance from the line of action from the force. So if we move across this way, we can see that it's perpendicular, and so the distance, the perpendicular distance here would be D, right? So from this diagram, the moment or turning effect produced would be the force F by the perpendicular distance D, and it will be measured in Newton meters. Fairly simple so far, right? So in this topic you have a couple similar terms that we use. So a few of them are, for moment, you would see torque, you would see turning effect. Well, you see that here already. And you would see turning effect as you see here. But we also have for perpendicular distance. So for these, you would see either lever arm or moment arm. Now this is basically to differentiate between perpendicular distance, which is what we want, and normal distance, right? So in questions, you would see the lever arm of the force acts at a distance of, let's say, 0.5 meters from the pivot, or you'd see the moment arm of the force acts at a certain distance, again 0.5 from the pivot. And this is just to differentiate within the question itself that they are giving you the perpendicular distance. If they are not, you would not see these terms used. You'd hear a question like the line of action of a force acts at an angle to the horizontal. Let's say I have a seesaw here, and the line of action of the force acts this way, and I have an angle here, and then they tell you that the distance from the line of action of the force would be, let's say, a distance D. You would actually have to use like triangles and trigs, all that good stuff, to find the perpendicular distance, because you can't use anything but perpendicular distance. In the first definition they said perpendicular distance, in the second one they said perpendicular distance, and this is what we need to find always. And remember I said that the distance is always in meters. So don't worry about this, we actually have another video calculating perpendicular distance that we would be uploading as well. So an important thing you need to know under this topic is the principle of moments. So this principle states that the sum of clockwise moments about a point is equal to the sum of anti-clockwise moments about said point. So we can shorten this and put the sum of CW is equal to the sum of ACW. CW being clockwise, ACW being anti-clockwise. So we can recall that moment is equal to force by distance. So from this principle, we can derive another formula. So F1 D1, which would be the clockwise moment, is equal to F2 D2, which would be the anti-clockwise moment. So from this principle, we can derive each variable. So for F1, if we transpose the formula, we would get F2 D2 over D1. For F2, if we transpose the formula, we'll get F1 D1 over D2. For D1, we'll send this across, so we get F2 D2 over F1. And for D2, we'd send this across, so we get F1 D1 over F2. Now this is very important, and the ability to transpose and get these values is extremely important for solving these questions. So if you need, you can rewind and go back and actually internalize how I got these, what moment really is, etc., etc. So now we'll be going into a couple questions. So in this is basically to show what we got before, the F1, the F2, the D1, the D2. So the first question is a seesaw question, and they're asking us to calculate Jack's weight, which is F1. So if Jack's weight is F1, Jill's weight would be F2, and the perpendicular distance, so we're good to go there, we don't need to calculate it. For Jack, since this one is one moment, and well, if you could see if Jack sits, he'll go this way, which is, if we have a clock, if we go this way, it is anti-clockwise, and if we go this way, it is clockwise, right? So this moment in the anti-clockwise direction would be F1 by D1, and this moment would be F2 by D2. So let's calculate. Always recall or state the principle of moments, right? So we know that the principle of moments is sum of clockwise is equal to sum of anti-clockwise moments, or we can write it the other way, sum of anti-clockwise equals sum of clockwise. For this question, we'll write it the other way because the anti-clockwise is on this side and the clockwise is on this side. So we'll line up the formula to suit. So we could say the sum of anti-clockwise is equal to the sum of clockwise, right? So we know that M, or moment, is equal to force by distance, and we just said that from this, anti-clockwise moment would be F1 by D1 is equal to the clockwise, which would be F2 by D2. So we can transpose the formula. So we're trying to find F1. F1 would be equal to F2 D2 over D1, which would be equal to F2 being 20 newtons by D2, which is 0.45 meters, over D1, which is 0.3 meters. So F1 would be 20 by 0.45, which is equal to 9, divided by 0.3, which is 30 newtons. Now we got newtons because the top would be Newton meters, and then if you cancel out, you'll get newtons. So that's the first one. So now we're gonna calculate for Jill's weight. So recall again the principle of moments. Same thing, Jack would be anti-clockwise, Jill would be clockwise. So we would still use this one, right? So, sorry, not this one. but this one. Right, so anti-clockwise moments is equal to clockwise moments. Now all of this is provided that the seesaw is balanced. Most likely they'll tell you this in the question, right? So this time F1 D1 is equal to F2 D2. Now Jack, the 30 newtons would be F1, this would be D1 because it's perpendicular distance. Jill would be F2 and this would be D2. So let's plug in the values, or we could transpose first. Let's transpose. We are trying to find F2. Now if you realize, I was right when I said I should have done it this way, but we could still do it this way. We'll do this one that way, right? We could still do it because you could do it any way you want. Just transpose the formula and you'll get through. Right, so F2 is equal to F1 D1 over D2. So F1 is 30 newtons by D1, which is 0.3 meters, over D2, which is 0.45 meters. So we already know that this force is going to be in newtons. And if we calculate this, let's clear this. 30 by 0.3 is equal to 9 divided by 0.45, which is 20 newtons. So Jill is 20 newtons. And you can see that we get the same thing. In this one, Jack was 30, and in this one, Jill was 20. So we're seeing that the formula proves itself correct, okay? So now we're going to do the same for distance. So for this one, Jack is going anti-clockwise, Jill is going clockwise, so we want to put anti-clockwise on the left hand side. So the sum of anti-clockwise is equal to the sum of clockwise moments, and so that would be F1 D1 is equal to F2 D2. Now this time we want to find D1, so D1 is equal to F2 D2 over F1, which would be F2 is, let's label F2 D2 F1, and we don't know the distance here, which is D1. See, it's perpendicular. So F2 would be 20 newtons by D2, which is 0.45 meters, over F1, which is 13 newtons. So in this one, cancel, so our unit would be in meters, nothing else. So 20 by 0.45 is equal to 9 divided by 30, 0.3 meters. Now from the question before, you see that we gain back the same thing, so that means the formula continues to prove itself. Now this one, Jack is anti-clockwise, Jill is clockwise, and we want to calculate the distance Jill sits from the pivot. Now you see in the similar terms coming back up, pivot, perpendicular distance, force, those sorts of things, right? So we want to calculate Jack is F1 D1, Jill F2, we want to calculate D2. So since this is in a clockwise motion, we'd put it on this side. So clockwise moments is equal to anti-clockwise moments. So now you realize what you have to do. So now that we're dealing with clockwise, it will be F2D2, because the moment on this side is formed by force 2 by perpendicular distance 2 is equal to anti-clockwise, which would be this side, which would be F1 D1. And we're trying to find D2, so D2 would be equal to F1 D1 over F2. Now if I'm going too quick, feel free to decrease the speed of the video, or actually like pause the video, complete it yourself, and then unpause it to get the answer from me. Anything you want to do to go at your own pace, feel free to do so. So F1 here would be 30 newtons by D1, which is 0.3 meters, over 20 newtons. Our cancel that, so we will have a value in meters. So 30 by 0.3 divided by 20 is equal to 0.45 meters. So now that we have gone through the calculations, I hope that, and the definitions, all of this that we went through, I hope that you understand moments or talk a bit more and understand how to do these basic lever questions. And yeah, so make sure to like this video, leave a comment of what other calculations you'd like to see, and don't forget to subscribe. Thanks for watching, guys.